Hey everybody, this is a power supply from the MidTower Deluxe. This is a dead power supply that decided to kill over on Easter Sunday of 2013. And while I did show you actually what failed inside the power supply, let's go ahead and take the cover off and do a teardown. I actually took this thing apart last week. I was going to try to get a video up, or at least record a video last week of the autopsy of this unit, but the Seaton Infinity 4 cable car TV tuner arrived in the mail, and I decided to go ahead and get the TV box back up and running. So now my computers are digital cable compliant in terms of their Windows Media Centers. Anyways, I'm going to take the cover off this power supply. I got the soldering iron heating up right now too. I'm not going to try to repair this thing, I just want to harvest it for parts. This power supply has 4 screws to take the cover off, and it's been sitting for over a week. The cover, for some reason on this power supply, is so aggravating to get off. I think the fan has a lot to do with it. The fan gets hung up on the front of the case. And you see I got this thing on bubble wrap because I'm trying to protect the casing. I want to save that and reuse it sometime. It's got a nice matte black finish on it. I kind of want to keep it looking good, not so scratched up. Yeah, it's this plastic on this fan that gets hung up. It's got a plastic sheet under it. There. And unplug the fan. I did a fan replacement on this power supply, I'd say about, I don't know, a year or a year and a half ago. The original fan still worked just fine. I just wanted to put a nice LED fan in it. Here's the original fan that came out of this power supply. Just your basic Hong Xing fan. Of course, obviously from China. But it still works just fine. Never had a problem with this fan. Bearings are just fine. But anyways, let's go ahead and have a close look inside this power supply to show you what exactly went wrong inside here. If you have a look next to the 5-volt standby transformer, you'll see what failed. That chip there is what failed. You know, what's funny is the top blew off of it and fell outside the fan, and when it did, it was glowing orange hot. You can barely see the chip. Let me get some light in there so you can see it better. Much better. You can actually see it now. The whole top of this chip, well, most of it, most of the top, completely blew off. This chip shorted out big time. And I believe this is a 5-volt standby controller. And what's funny is the chunk that fell out of the power supply casing has the part number on it, or the model, or whatever you want to call it. I was able to look up a data sheet on it. There's your part number is TNY278PN. This is a tiny switch 3 integrated circuit. And something went wrong with this power supply. I'm not sure if this chip itself shorted out or something else shorted, taking the chip out with it. The computer is perfectly fine. It did not hurt anything inside the computer. MidTower Deluxe is running a brand new Thermaltake 750W smart M750w modular power supply. So anyways, this is going to give an overall look at the build quality on this power supply. First, we'll look at the filtering stage, primary filtering stage. Right here we have 2 white capacitors and the next capacitor. It's a good way to start out with. The wires run through an additional ferrite core which is in that sleeve there, that heat shrink sleeve. And that all goes into the case. Goes into the PCB down there. And if you have a look at something, I'm not very crazy about their work, their soldering work. Get you a focus here, you can exactly see what I'm talking about. Not very crazy about this, which there's the fuse. Look at it's on the live hookup. You see the excess wire there, you can see it now. You see the excess wire that's sticking out. And that's not very good in my book, at least in my opinion. And let me go ahead and test that fuse with my multimeter. Make sure it's good or if it's bad. I don't think it took out the fuse when it failed. Anyways, I'll grab my multimeter and set the continuity and we will see. Okay, so I set my multimeter to continuity and let's go ahead and check this fuse. It's exposed easily so you can check it. And it looks like it might be replaceable by the way it's in there. Fuse is good. No problems with the fuse. It didn't put out that many fireworks when it failed. Now, of course, I didn't get video of that because I wasn't expecting a failure. And of course, if you're wanting more information about the failure and replacing the power supply, I got videos up about that, so you can go check those out. Anyways, moving on. The filter stage continues right through the fuse. We have a coil here, X capacitor, 2 more Y capacitors, and another coil, and there's one MOV that's crammed between the second coil and the bridge rectifier. A lot of power supplies out there actually have 2 MOVs. This one has just one, which, I mean, it still has some sort of protection, but it's not the best. Our bridge rectifier is a GBU 605. We have 3, actually take that back, we have 2 K4106, they're switchers for PFC control. There's a PFC coil, it's not that big. I'm going to compare it to the coil that's in the Thermaltake. Thermaltake also has 2 bridge rectifiers in parallel, rather than just one by itself, but at least they did heatsink this bridge rectifier, so it's built fairly decent, but it could be better. There's a small transformer there. I believe that's a step-up transformer, because the way PFC works is it usually wants to step up the voltage from what goes into the power supply to about 300 something volts, something like that. There's a TPO 400 volt 330 microfarad capacitor. This capacitor is beefier than what you would find in some other power supplies. This is pretty average among probably a 650 watt power supply. And that capacitor is actually bulging a little bit. If you have a look, this will be the first time I've ever seen a primary capacitor power supply bulge like this, but if you look at it from this angle, you can see it bulging. It's not bulging a whole lot, but it's bulging some. That's definitely something I'm going to look at. I think I'm going to take that capacitor into the lab at CPCC and hook up to the LCR meter and see what it's actually charging to. Anyways, moving on. We have 2 K4106 switchers on the first heatsink. There's your transformers. Primary transformer, the main transformer, and you have a 5 volt standby transformer down there. And on a secondary heatsink, all the the rectifiers are exactly the same. Every one of them's the same. We have a diode down on the very end, and I believe that's probably for, I guess, maybe 5 volt standby or something else. I'm not 100% expert at power supplies, but any of y'all out there who are experts with power supply know exactly what that is. It's this diode by itself. And we have 4 D. Let me see. I know you can't see, but it's D83004. Rectifiers are all the same. This power supply, it's kind of funny to note, but this power supply, every output on it says 25 amps. 3.3 volts, 25 amps. 5 volts, 25 amps. Both 12 volt rails are 25 amps. And seeing that there are 4 rectifiers in here, these are Schottky rectifiers. This thing may actually have 2 12 volt rails, though I'll know for sure when I take the PCB out and have a look. Anyways, let's look at the secondary side a little bit closer, and then we'll go ahead and start tearing this thing apart. On the secondary side, we have capacitors by the brand REC. I thought it was actually PEC in my last video, but it appears to be REC. These caps are holding up just fine. This power supply has been in service from September 2010 through March 2013, so it's lasted a pretty good time. Most of its time it was served pretty heavily loaded systems, I guess, for this power supply. I mean, my system had 3 hard drives, a 125 watt CPU that was overclocked, for most of the time water cooling system, 2 optical drives, video card. Now it has a 6750 which requires a connector, PCI Express hookup, has a TV tuner, 2 Ethernet adapters including the onboard, and it has a modem, that kind of stuff. So pretty major system if you consider that, especially when you have multiple hard drives running all the time. And this thing never cut off, and it was on all the time, so I can't complain too much about it, especially when I got it really for like 20 something bucks out of a parts machine from Goodwill Computer Works store. That's what this was in. I didn't buy it new from Newegg. I was kind of skeptical when I saw the CaseGears logo on it, because normally CaseGear power supplies aren't that good of quality, but this one here is fairly decent. Which, by the way, those Schottky rectifiers are rated for 30 amps apiece, so that's not too awful bad. So now I'm going to go ahead and take the PCB out of the case, and we'll have a closer look at this thing. Okay, just got the PCB loose from the power supply, but I still gotta disconnect the AC leads. But I want to show you something here. Right here is mains voltage. This is actually under the X capacitor. Notice we have 2 resistors here, wired in series. This here is to drain out the power supply's capacitor. I will believe this anyway. I can't be 100% sure, but I'm looking through here. I'm finding resistors, surface mount resistors, under here to, I guess, to help discharge this capacitor. It was fully discharged, by the way, and that's why I always say it's good to let a power supply sit for a while, especially when one failed like this, where the 5 volt standby chip just blew off the board. And I believe when it blew off the board, it went open circuit, because see, that's all it was. When this thing blew up, it popped this out, but did nothing else from the time this popped to the time I unplugged it. So anyways, that being said, the soldering quality is actually pretty decent on this power supply. I'm still trying to find an OEM on this thing. This may be a bit difficult, because I'm not an expert at identifying the OEMs of these things. Okay, the power supply board is separate from the case. There's a power supply board. There's a case. There's something funny. Look at this hair inside of here. It's a very thick hair, and it's black. I'm assuming this hair was also made in China. My hair's not like that. Nobody else I know has hairs like that. I think somebody lost a hair when they was manufacturing this power supply. So there it sits. Somebody from China. This is one of their hairs inside a power supply. Now I'm going to go ahead and close this power supply case up, and I'm going to store it up. I mean, it's very nice looking, very sturdy case. I mean, most cheap power supplies, you can just bend them with a finger. This one here is very sturdy. Very good quality switch. Good receptacle. And of course, I already got part of the EMI filtering stage started here with this X cap. There's a bleeder resistor under there. You got, again, I already showed this to you, but we got two Y caps and this inline inductor. I'm going to close this back up. I'm going to store it. Here's a look at the PCB outside the case. You can really get a good look at it now without the case being in the way. Again, there's the primary filtering stage. The PFC is controlled by this IC here, which is a CM6800G. I haven't looked up a data sheet on that one yet, but I did look up the data sheet on this chip. This is a PS224. This is a monitoring circuit here. So maybe this one here actually controls the power supply. This one here is for monitoring. Let's get you a good focus. Again, there's those two chips. Now I looked up the data sheet on this chip here. And let me just go ahead and have a look and see what it offers. This chip offers over voltage protection, over current protection. So here's features: over under voltage protection, over current protection lockout, additional protection input, fault protection output with open drain output stage, open drain power good output signal for power good input, built-in 300 millisecond power good delay. This is the AC on 75 millisecond delay for under voltage over current protection. Blah blah blah. So it's not too bad. And there's your diagram of the chip. So anyways, it does have over voltage, over current protection too. So that's not too bad. A lot of cheap power supplies out there tend to lack some of these things. So we know this power supply has short circuit protection and over voltage protection. That's good for your computer. Anyways, now for the fun and games. Let's go ahead and start tearing it down. Okay, here's the burning question. I figure I'm going to answer this before I go and tear this thing down. Is this a true dual 12-volt rail power supply? Well, according to the PCB, it actually is. It's funny, most of the yellow wires are for plus 12-volt 1. And we have only 2 wires for the second 12-volt rail, which makes not that much sense. Now, so we'll go ahead and have a look here where these 2 wires go. They have a green backing on them. And they go to, let us see here. They go to one of the CPU connections. So it's funny, the CPU is being fed by both 12-volt rails. So it gets equal share of both 12-volt rails, so that's not too bad. So really, if you think of it, with, let's say if you're using a CPU that has the EPS 12-volt connection, the processor is actually getting fed by both 12-volt rails, so you have a maximum of, at least what this power supply says, 50 amps when you combine them together. But obviously that's not usually the way it works. You usually have a combined rating that's not as high as both added together. They didn't bother to include that information. But seeing these components, these switching components, are rated for 30 amps a piece, you could probably get up to 60 amps out of this, unless the overcurrent protection goes in and stops. Okay, now you're looking at the results of the teardown. I don't always go as far as to actually tear down the PCB to the point where the heat sinks and stuff come off, but I have really given this thing a nice little teardown. I didn't get everything off of it though. I did get most of the capacitors, at least the electrolytic caps. Many of the inductors, I got those too. This one here and these 2 pipe filters are still on here though. I might get those later on. The main transformer and the 5-volt standby transformer are still intact. This is the PFC transformer. Here's the underside look at the board. Now, all you guys out there that are really good with power supplies in terms of knowing the brands, here's something that might get you a clue. Let me just see. I know I saw some, I think it's on the other side of the board, but there's the fuse warning. Tells you that for continued protection against risk of fire, replace only with same type and rating of fuse. Let me flip this over. Well, first, here's a look at the transformer. Sometimes looking at the transformers can get you a clue of what the OEM is. Let's go ahead and flip this over. But before I do, the secondary side inductor is built very well. It's actually mounted to its own little frame, if you want to call it that. A little fiberglass frame, and then it's actually soldered to the PCB. And here's something else on the PCB. It's located right here. It says 48.00636.008C, and there's also WZW there. That might be something, a little something that might ID this power supply's OEM. If any of you guys out there who are good at power supplies could figure this out, feel free to let me know, because I'm kind of curious who made this thing. And I went ahead and took all the heat sinks off and their components. This is the bridge rectifier and the PFC switchers. These are identical to the ones on the main switchers. These are all K4106, which I believe are made by Toshiba, but I'm not sure. I couldn't really find a data sheet on these, so I can't really give you the specs on them. Here's a close-up of one. This here is just a regular diode. See, it's got two legs on it. These are both switching transistors. There's the bridge rectifier, which is heat sinked. It's a GBU 605. Probably a 6 amp rectifier, not really sure. Anyways, that being said, this is the heat sink with the two main switchers. Like I said, these are also K4106 switchers, switching transistors. There's two of them. So I have a total of 4 of these, counting the ones on that other heatsink. Starting to have some nice little parts here. And on the secondary side heatsink, we have 4 identical secondary side rectifiers. These are D83-004. I believe I mentioned this earlier in the video, but this is really a closer look at them. And the data sheet on these mentions that they're all rated for 30 amps. Now, of course, this is 25 degrees Celsius ratings, and your power supply will get a bit warmer than that, so it's pretty safe to say that this power supply actually met its label, if you want to call it that. Every every secondary rectifier on this thing met the ratings. We have 2 for the 12 volt rails, 1 for the 5 volt rail, and 1 for the 3.3 volt rail. And it's funny, they're all the sticker says that all those rails are rated for 25 amps a piece. This here is another diode, and of course these are Schottky diode packs. I'm going to set these heat sinks to the side. Let's look at the inductors I pulled off. I pulled off one of the pipe filter inductors. That's what these are referred to as. These are the 2 input stage EMI filtering inductors. These are sometimes referred to as long coils, I believe. You have 4 legs on them. So you have 2 actual series windings in these coils. One for live, one for neutral. These are actually AC. AC runs to these. This here is the PFC coil. This is a giant series winding. Now, of course, I don't know what the Henry ratings on these are, because I haven't tested them in the lab at CPCC yet. I might do that sometime pretty soon, just for curiosity. It's a good heavy inductor right there, though it's not near as big as the one that's in the Thermaltake power supply. This is, I believe, the 3.3 volt inductor. Come off the secondary side. There's 2 series windings together. These 2 series windings were actually run together in parallel. So I guess I should call them parallel windings. Here's a look at the PI filter. This here came from the middle of the power supply between the two heat sinks. This is next to the transformer. It used to go right there on the PCB. Let's look at the capacitors. Many of the caps on this power supply are 3300 microfarad 6.3 volt caps, and on the 12 volt rail or rails we have REC 2200 microfarad 16 volt caps. Now one of them actually got chunked in the trash can. When I got loose on the board, it slung and actually landed in a trash can and couldn't get it out of the trash. But yeah, big deal. I got many more caps. Another 3300 microfarad 6.3 volt cap. And these caps have been in service in this power supply for, let's say, about 2 years, something like that. No bulging at all, so I'm going to actually reuse these. Now, of course, there's no telling whether they're truly good or not, so what I'm going to do is I'm going to take this one here, since it's less than 1000 microfarads, it's a 470. I'm going to take that into the lab at CPCC and test it on our LCR meter. Here's a look at that primary TPO capacitor. You can really see it's actually bulging. It's a good look at it, and if you flip it upside down like this, it doesn't sit up straight. I mean, it wobbles around. And when caps wobble around or fall over, it's usually when they're bulging on top. I'm going to be taking this big guy into CPCC and testing him on the LCR meter. I'm curious to see what he can do. Not really sure. Bulging pretty good. I tell you what's pretty unusual, at least, to see primary caps bulge. I mean, I don't see them bulge very often. Even TPO caps, Capzons, you name it. I've actually reused some Capzons in a cheap Diablo-Tech power supply, or Diablo-Tech, how you pronounce it. That's in the TV computer. That power supply had only 330 microfarad caps. I put some slim 470s from a Bestech into that power supply when I recapped it. Anyways, here's the next capacitor. Two white capacitors right here. So anyways, we got some good components out of this power supply. And here is a good look at that blown chip. Have a look at this. Now if the heat sink's out of the way, you can get a really good look at this thing. Have a look at that. It blew up quite nicely. Anyways, that was the teardown of the MidTower Deluxe power supply. So that way, if you come across a CaseGears EcoElement 650w power supply, it's safe to say there's nothing really wrong with using it. I mean, on the EPS 12 connector, two of the 12 volt leads come from one rail, two of the other leads come from the other rail, so you have a combined. For your CPU, it's built it's designed pretty well, so that way the CPU gets access to both 12 volt rails. So this thing is definitely designed to give plenty of 12 volt power to the CPU. Now I don't know what the combined rating of those two 12 volt rails together are, but we do know that these components are rated for 30 amps apiece. And I'm going to safely assume 25 degrees at probably 40 to 50 degrees Celsius operation. I think I also forgot to mention, I got these resistors out of this power supply too, and I think these are referred to as defrost resistors. At least that's what I've seen online. I'm not sure what the values are of them, but I figured what the heck, go ahead and pull them off. But anyways, that concludes the teardown of this power supply. And I got two other power supply circuit boards here. This is the one out of MidTower Deluxe. I got these here for another video I'm going to make. So anyways, any questions or comments? Feel free to ask, and thanks for watching.